So, good morning again. So, we're going to be on chapter 1.3 and we're on page 36. And what we're looking at is something new, and it's called function notation. Now, they give you a problem on page 136 where a t-shirt company charges you $8 a shirt plus a one-time setup fee of $15. So maybe I want to have team shirts made, and I don't know, there's 10 people on my baseball team. So I insert 10 into this position, and that's going to tell me 8 times 10, and it's that's exactly right, it's 80. But don't forget the one-time setup fee, so that's going to give me a price of $95. Okay? And you're used to writing equations that look like that. Function notation is slightly different. The way you write it is function of x equals 8x plus 15. Now, if I put the 10 in there, function of x is 10, x is 10, the function of x would be 80 plus 15, $95. Now, you're probably saying to yourself, well, wait a minute, that's the same thing. Absolutely right. It is the same thing. Function of x is equal to 8x plus 15, and y is equal to 8x plus 15 is exactly the same thing. Why do they do that? Because they're mathematicians and they have to, make everything complicated. But it's not that hard. Just think, if you like, function of x is the same thing as y. Now, on page 139, they start talking about different types of functions, and they talk about increasing, decreasing, and constant. Increasing functions, exactly what it sounds like. Let's say I had function of x equal 2x. As you increase the number here, 1, 2, 3, 4, y, or function of x, is going to increase. 1 times 2, 2. 2 times 2, 4. 3 times 2, 6. 2 times 4, 8, and so on. As you do this, the function is going to increase. Now, you can make a function decrease too, even if the numbers you're putting in are getting bigger. Let's take that same problem, only this time, let's make it negative. So 1 times negative 2 is negative 2. 2 times, if I put in a 2 there for the x, 2 times negative 2 is negative 4. If I put a 3 in there, negative 2 times 3 is negative 6. If I put a 4 in there, negative 2 times 4, wait a minute. You'll notice these numbers are getting larger, but these numbers, you're going further in the hole. These numbers are getting smaller, so the overall function is doing that. Now the last one, constant, and it's just what it sounds like. There's no change whatsoever, okay? How could we do that? How could you write a function where all the time it just stays the same? Well, how about if I said that function of x is equal to 2? So in other words, it wouldn't matter what x value I put in, the y value would always be the same. So when you did that, you started putting your dots. If the y is always 2, no matter what your x is, oh, wait a minute, that's a flat line. In other words, it's constant. So if you see an equation where you don't get any change, or you graph it and you get a flat line like that, you're looking at a constant function.